All right, let's take a shot at 5-5 here. Function operations. The math here isn't what's so tricky. It's just a whole bunch of new notation that you may not have seen before. And so try not to get too tricked by just the notation, or open your mind to the notation, maybe is a better way to say it. So these two functions that were given here, f of x being 3x plus 4 and g of x being x squared minus 5x plus 2, and they say find f minus g, and sometimes that will even just be written like f of x minus g of x. And sometimes you might even see it written as f minus g of x, like that. But all of those really can just mean, they all mean the same thing. So in this case, all it is your f of x function, your 3x plus 4. Subtract away your g of x function, x squared minus 5x plus 2. So it's just like we've done before with polynomials, just like combining your like terms. And your answer is just going to be a formula when you're done. So this 3x, and then this minus 5x, this minus x squared, I'll write it in standard form with the highest degree first. 3x minus 5x would be plus 5x, so that'd be 8x. And then this 4 minus 2 would leave you with 2 positives. So that's all you need to do for the f minus g of x there, or any of those other forms that sometimes it's written in. And then this second one, just add them. So again, this could be the same sort of thing. They might write f of x plus g of x. You might also see f plus g of x. So they're all going to mean to do the same thing. The 3x plus 4, and add on to it your x squared minus 5x plus 2. And in my standard form, highest degree first. 3x plus a negative 5x would be negative 2x. And then 4 plus 2. And so it would just look like that. Continuing, next one says you have like a little bit of a word problem. The demand for a phone is based on the price. So the demand, where x here, the price is x. If the x is a price, the more x goes up, the demand goes down. So if you think about this, for every $1 more x goes up, we're losing 10 more. So said another way is, for every dollar increase, demand decreases by 10. Dollar price, $1 price increase equals 10 fewer in demand. And so I have a note over here to also remember to, in the domain, remember, since we're talking about price is x, I don't think you're gonna like pay people to take them, even though sometimes it almost seems like they do. So your domain, if you gave them a way to attract customers, you could put a square bracket. If you're saying you're gonna just charge something, parenthesis, and then what would be the maximum that you might. And so if you come over here, if your demand became negative, so 5,000 minus what would it make it so your demand is actually 0, and that would be 500, because 500 times 10 is 5,000. So I would say you would go up to 500. And if somebody else says, no, we're not going to price it to the point that we actually have 0 demand, so then your domain, they call that a practical domain. And then for that, sometimes there's a little bit of like real life thinking, discussion that comes into it. And so somebody else might be a little bit arbitrary over here then at that point. So just to kind of keep that in mind, those are my domains. The revenue equals price times the demand. So if X was the price and the demand is this 500 or 5,000 minus 10x, the total revenue we're going to take in would be our price for selling each phone for, and then times how many of them we're going to sell. So this right here would equal our total revenue that we're ever going to get. And if you think about what that looks like, you've got a 5,000x here, And then this negative 10x squared, I'll put that in front for standard form. And so this is a parabola opening down. Well, it kind of makes sense. At some point here, you don't sell or you don't get any money because of the fact that you're giving them away. And then over here, they're overpriced, so nobody's buying them. And so someplace in the middle, there's that, what I always refer to as the sweet spot, where you sell the right amount of them so you make the maximum amount of revenue. So that is one of the ways you can interpret. And then remember this practical domain over here. Some of that's arbitrary, some of it is found by looking at the problem. So this would be like my 500 here. When I no longer have any demand, this is my 0. But again, somebody else might say, no, we're not going to go that far. We're going to at least make this amount of money here and here and use those 2 points. So what about if they give us a problem here that involves a quotient? So quotient means a fraction, answer to a division problem, right? So in this problem, if I have, they want f of x over g of x. So f of x over g of x, that's the x minus 7 right here. And they want to put that over my g of x, the 2x squared minus 13x minus 7. And I've got this note over here saying you got to simplify that. So one thing that hopefully you kind of think of right away as well, simplify, you got to take out, this is a factor. So you got to have that whole thing as a factor. See this 7 here? It makes me think, I wonder if x minus 7 is one of my factors for this denominator, 2x squared minus 13x minus 7. Well, if it is, x times what makes this 2x squared? That'd have to be a 2x. And negative 7 times what makes this negative 7? That'd be a plus 1. And then just double check and see if it does work here. We've got a 1x there for the middle. We've got a negative 14x there. And when you combine these two together, does that make my negative 13x in the middle? It sure does. So now what happens here is this factor and this factor divide out. Just like if, let's say I had 2 over 3 times 2. This is like 2 over 6, right? And so you've simplified those for a long time where you can divide them both by 2 and get a third. It's like right here, you take those out. 2 divided by this 2 is a 1, and that's a 1, so you have 1 on top and 3 times 1, a third on the bottom. Same thing back over here. So you've got this x minus 7, that x minus 7, because it's multiplied in between there. So this one divides out to a 1, and my final answer then for this problem in simplified reduced form, 1 over 2x plus 1. Now there's a couple of things you have to consider here as well. If you went back to this problem and had, think about x, if x were a 7 in here, then I would have 0 times the 2x plus 1, whatever that is, 1. 0 times 1 would be 0. Can you have 0 in a denominator? No. That's dividing by 0, it's undefined. So x cannot be 0 because of this factor. And then what about the one that we even had left in our answer? When does 2x plus 1 equal 0? If you think about equals 0, subtract 1 to the other side, divide by 2, so negative 1/2. So either one of those have to be eliminated as options. And so as long as we have that here, I'll point that out. We're going to use that in the future anyway. But those are sometimes referred to exclusions, unincluded, not included, just sometimes solutions that you have to make sure wouldn't make your original problem undefined. All right, the next thing is called composition of functions. So over here, I'm going to tell you my 2 functions we're using on this problem. F of x is x squared and g of x is x plus 1. And so then the next thing over here, just 2 different ways of writing the same problem. Sometimes this is the dot notation, f dot g of x. it really means the same thing as what I showed over here. You're going to take the G formula and put it in place of X in F. So let's see how that looks. Take my G formula and put it into F. See how it's inside the parentheses here on F? Here's my G formula. And they stuck it in place of this X, so then you put it in place of that X as well. So in our problem right here, instead of this X right here, I'm going to have X plus 1. It's going to be X plus 1 squared. So if this textbook seems like it usually wants you to work these out. And then FOIL that out. X times X, X squared, 1X there, 1X there, there's 2 X's. And 1 times 1 is your 1 there. Continuing from there, the next one is just sort of like the inverse order of that. So when it says G dot F of X, that means you're putting the F formula into G. So notice how I sort of just move these parentheses around here. When you go over here to this form, the letters stay in the same order, but you're just nesting the parentheses. And for me, this writing it this way just makes more sense to me what I'm really supposed to do, because like on this one, I'm taking my F formula and I'm going to put it in place of the X in G. So I'm putting the F formula into G when it's inside the parentheses there. So on this one, take the X squared from F and put it in place of this X. So this one's just X squared plus 1. Now, if you go over here to the last one, I should have started with this because it actually usually is a little bit easier. This first one, somebody might have written, looks like fog, F dot G of 3 is another way to write that, but it's in the nested parenthesis form. Again, it just makes better sense to me in my brain. I'm going to put 3 into G. So you come up here, put a 3 into here, that'd be 4. 3 plus 1 is 4. So this whole G of 3 is just a 4. And then I'm going to do F of 4. So I'm putting a 4 into F. So when I go up here, that's going to be just, first it was 4, wait a minute, 3, and then I put in to start to get the 4. 3 plus 1 was first in here, and then I put it in there, which squared, so I got a 16 sort of. The next one, I put a 3 into F, so that's 3 squared 9, and then I'm going to put the 9 into G, so 9 plus 1 for a final answer of 10. Notice that when I have numbers here, I get numbers answers. And if I have an X in here, my answers look like these formulas. So just to practice another one here. Again, I like to rewrite these as F G of X so that I'm putting my G formula into F. I'm going to take this and put it in place of that X right there. So it's going to be the square root of 2x minus 5 plus 7. Putting the G formula in place of this X right here, and then simplify it down. So 2x plus 2. Next one, again, I like this nested parenthesis way of writing it myself. So G of 3, put a 3 into G. 6 minus 5 is 1. So G of 3 is 1. This whole thing in here is just a 1. And I'm going to do F of 1, so put a 1 into F. Square root of 1 plus 7 would be the square root of 8. I'll remind you that you're supposed to simplify those. Square root of 4 here is this 2 that got out. Okay, so far so good there, I hope. The next one, now technically here, we could have taken this 3 because f dot g of x, we found that formula, so f dot g of x here, we could have put that 3 in there. 2 times 3 is 6 plus 2 was 8, and you could have gotten it right here as well. I'll try that on this next one. So this next one, I'm going to do the nested parenthesis, it's g dot f of x. So I'm going to go g of f of x. So take your f formula right here and put it into g in place of the x right there. So it's going to be 2, and then this whole square root of x plus 7, and then minus 5. Again, the f formula is going right here. So I got my 2. In place of this x, I'm putting this f of x formula, square root of x plus 7. And then I've got this minus 5 sitting outside after that. And then I don't think you can even simplify that. Now this next one, like I said on the last one, I showed you how to do this all over down here on the bottom left with the number. On this one, see I have my g of f or g dot f. And I'm going to put the 2 up there in place of x. So I've got my 2 outside, 2 plus 7 under the square root, and a minus 5 sitting outside. So that's 2 times the square root of 9. I normally would have jumped right to 3 there and probably changed this whole thing into 6 and minus 5 and gotten a 1. So if you can do more of that in your head, I encourage you to do that. So, and skip all these steps that I'm writing. I'm just doing that so I hopefully don't leave anybody behind here. So hopefully even all this, maybe a lot of people, that whole thing there, everybody, they could just do in their head and get to your answer of 1. Your brain can think a lot faster than your hands can write it. All right, continuing. So another, it's like this one's talking about clothing sales, and X is the price of an item. If they give you $5 off, that looks like the price minus 5. If they give you a 10% off discount, the price minus 10% of it, a whole X take off 10 point or 1/10 of it, leaves you with 90%. So I sometimes think of this as, if it's 10% that's taken off, what percent do I still pay for? And that would be like I'm paying for 90% of the price there. So sometimes I'll think of that way. Now they ask us to, how do these look if we do them as a composite function? So if I'm going to do the 10% off first, X is my price, and my 10% off first, that's my g of x. So what goes inside of here is the first thing I do, just inside the parentheses, and then, so out here, then I'm going to do my f of x second. So 10% off first, the g of x is the 10% off, and then outside of the parentheses, if you do your nested parentheses. So how does that formula look? Take my g of x formula, right there, and put it in place of that x, right there. Okay, so put my g of x in place of the x, and I've got 0.9x minus 5, if I do it in that order. Take the second option. So the second option says, first take your $5 off, that's your f of x. That's the $5 off. And then after you do that, do the 10% off, which is your g of x. So that would look like this order. And again, how does that work? Take your f of x formula and put it in place of your x here. So it'd be 0.9 times that x minus 5. All right, so how's that look? By 0.9, and in place of that x, put your x minus 5. Multiply that out. 0.9x, and 9 times 5 is 45, so this must be 450. And so then the question becomes, which one of these gives you a better deal? So you see the 0.9x in both of them, but this one takes off $5 after that. This one takes off $4.50. So if you're the store, you're going to want to advertise it this way because you're going to get more money. If you're the person that's shopping, you're going to want this method because you actually pay less. So just an example of how you can use the composite functions to solve sort of a real life type of problem.